In case of Harvard architecture, the very important distinction or difference it has with von Neumann architecture is that the memory in which code is stored or instructions are stored is kept separate from the place where data or values are stored. Okay, while in case of von Neumann architecture, both whether it is code, whether it is data, everything is stored in the same memory location. Okay, if you know this difference, only then you can understand all other differences. Okay, so as soon as you know program and data memory are two different two different memories, and it is not the same memory, or both code and instruction code and values are not stored in the same location, immediately you will know that you need separate buses are nothing but connections of wires connecting CPU to these memories. Okay, they will be separate. Okay, to whether we are fetching instruction, then you're using this particular bus, and if you're fetching data, you will be using this particular bus. But in this case, because data and instructions both are stored in the same memory, there will be single shared bus. As soon as you know the components are different, wires are different, immediately you should know that pipelining becomes easy in case of Harvard architecture. Okay, because these two tasks can be considered as two separate tasks. Okay, while here it doesn't become two separate tasks because you will be using the same connection to get the data. You can't simultaneously fetch program and data, but here you can do that. Okay, so pipelining becomes easier here, and again, because there are separate wires doing their respective task, parallel tasks can happen, because of which performance is increased and speed is increased. But here performance is not that good. Okay, because of the additional components, memory components, additional buses and all, immediately you should know that cost is high here. Because of the absence of all that, it is cheaper here. Okay, then we have no memory alignment problem. Why? Because we already know data and instructions are stored in two different memories. Okay, because of which overwriting of a program, or if some data is there, modifying that, or any sort of corruption doesn't happen in case of your Harvard architecture. But when it comes to von Neumann architecture, because code and your data stays in the same location while program is run, okay, while executing the instructions, modification can be done in the code, or modification can happen in the code. Any sort of overwriting, all those things can happen here. Okay, now here, since data and instructions are stored physically in different locations, no chances of accidental corruption. So what problem we see here, it is not seen here. Since data memory are stored physically in the same chip, there are chances of accidental corruptions. Okay, so that's all about the difference between Harvard and von Neumann architecture.